Section 3B.4 Our Divided Brain. What do split brains reveal about the functions of our two brain hemispheres? For more than a century, clinical evidence has shown that the brain's two sides serve differing functions. This hemispheric specialization, or lateralization, is apparent after brain damage. Accidents, strokes, and tumors in the left hemisphere can impair reading, writing, speaking, arithmetic, reasoning, and understanding. Similar lesions in the right hemisphere have effects that are less visibly dramatic. By 1960, many interpreted these differences as evidence that the left hemisphere is the dominant or major hemisphere, and its silent companion to the right is the subordinate or minor hemisphere. Then researchers found that the minor right hemisphere was not so limited after all. The story of this discovery is a fascinating chapter in psychology's history. 3B.4.1 Splitting the Brain. In 1961, two Los Angeles neurosurgeons, Philip Vogel and Joseph Bogan, speculated that major epileptic seizures were caused by an amplification of abnormal brain activity bouncing back and forth between the two cerebral hemispheres. If so, they wondered, could they put an end to this biological tennis game by severing the corpus callosum, figure 3.32, the wide band of axon fibers connecting the two hemispheres and carrying messages between them? Vogel and Bogan knew that psychologists Roger Sperry, Ronald Myers, and Michael Gazzaniga had divided the brains of cats and monkeys in this manner, with no serious ill effects. So the surgeons operated. The result? The seizures were all but eliminated. Moreover, the patients with these split brains were surprisingly normal, their personality and intellect hardly affected. Waking from surgery, one even joked that he had a splitting headache. Gazzaniga, 1967. Sperry and Gazzaniga's studies of people with split brains provide a key to understanding the two hemispheres' complementary functions. As figure 3.33 explains, the peculiar nature of our visual wiring enabled the researchers to send information to a patient's left or right hemisphere. As the person stared at a spot, they flashed a stimulus to its right or left. They could do this with you too, but in your intact brain, the hemisphere receiving the information would instantly pass the news to its partner across the valley. Not so in patients who had undergone split brain surgery. The phone cables responsible for transmitting messages from one hemisphere to the other, the corpus callosum, had been severed. This enabled the researchers to quiz each hemisphere separately. In an early experiment, Gazzaniga, 1967, asked these patients to stare at a dot as he flashed HE.ART on a screen, figure 3.34. Thus, he appeared in their left visual field, which transmits to the right hemisphere, and art in the right field, which transmits to the left hemisphere. When he then asked what they had seen, the patient said they had seen art. But when asked to point to the word with their left hand, controlled by the right hemisphere, they were startled when they pointed to he. Given an opportunity to express itself, each hemisphere reported what it had seen. The right hemisphere, controlling the left hand, intuitively knew what it could not verbally report. When a picture of a spoon was flashed to their right hemisphere, the patients could not say what they had viewed, but when asked to identify what they had viewed by feeling an assortment of hidden objects with their left hand, they readily selected the spoon. If the experimenter said right, the patient might reply, "What? Right? How could I possibly pick out the right object when I don't know what I saw?" It is, of course, the left hemisphere doing the talking here, bewildered by what the nonverbal right hemisphere knows. A few people who have had split brain surgery have been for a time bothered by the unruly independence of their left hand, which might unbutton a shirt while the right hand buttoned it, or put a grocery store items back on the shelf after the right hand put them in the cart. It was as if each hemisphere was thinking, "I've half a mind to wear my green-blue shirt today." Indeed, said Sperry, 1964, split brain surgery leaves people with two separate minds. With a split brain, both hemispheres can comprehend and follow an instruction to copy simultaneously different figures with the left and right hands. Franz et al. 2000. See also figure 3.35. Reading these reports, I fantasize a person enjoying a solitary game of rock, paper, scissors, left versus right hand. When the two minds are at odds, the left hemisphere does mental gymnastics to rationalize reactions it does not understand. If a patient follows an order sent to the right hemisphere, walk, a strange thing happens. Unaware of the order, the left hemisphere doesn't know why the patient begins walking. Yet, when asked why, the patient doesn't say, "I don't know." Instead, the interpretive left hemisphere improvises, "I'm going into the house to get a Coke." Thus, Michael Gazzaniga, 1988, who considers these patients the most fascinating people on earth, concludes that the conscious left hemisphere is an interpreter or press agent that instantly constructs theories to explain our behavior. These studies reveal that the left hemisphere is more active when a person deliberates over decisions. Rogers, 2003. When the rational left brain is active, people more often discount disagreeable information. Drake, 1993. The right hemisphere understands simple requests, easily perceives objects, and is more engaged when quick, intuitive responses are needed. The right side of the brain also surpasses the left at copying drawings and at recognizing faces. The right hemisphere is skilled at perceiving emotion and at portraying emotions through the more expressive left side of the face. Right hemisphere is skilled at perceiving emotion and at portraying emotions through the more expressive left side of the face. Figure 3.36. Right hemisphere damage therefore more greatly disrupts emotion processing and social conduct. Tranel et al. 2002. Most of the body's paired organs, kidneys, lungs, breasts, perform identical functions, providing a backup system should one side fail. Not so the brain's two halves, which can simultaneously carry out different functions with minimal duplication of effort. The result is a biologically odd but smart couple, each seemingly with a mind of its own. Section 3b.5, right-left differences in the intact brain. So what about the 99.99+% of us with undivided brains? Does each of our hemispheres also perform distinct functions? Several different types of studies indicate they do. When a person performs a perceptual task, for example, brain waves, blood flow, and glucose consumption reveal increased activity in the right hemisphere. When the person speaks or calculates, activity increases in the left hemisphere. A dramatic demonstration of hemispheric specialization happens before some types of brain surgery. To check the location of language centers, the surgeon injects a sedative into the neck artery feeding blood to the left hemisphere. Before the injection, the patient is lying down, arms in the air, chatting with the doctor. You can probably predict what happens when the drug flows into the artery going to the left hemisphere. Within seconds, the person's right arm falls limp. The patient also usually becomes speechless until the drug wears off. When the drug enters the artery to the right hemisphere, the left arm falls limp, but the person can still speak. Which hemisphere would you suppose enables sign language among deaf people? The right because of its visual spatial superiority, or the left because it typically processes language? Studies reveal that, just as hearing people use the left hemisphere to process speech, deaf people use the left hemisphere to process sign language. Carina et al., 1992. Hickok et al., 2001. A stroke in the left hemisphere will disrupt a deaf person's signing, much as it would disrupt a hearing person speaking. The same brain area is similarly involved in both spoken and signed speech production. Carina, 1998. To the brain, language is language, whether spoken or signed. Although the left hemisphere is adept at making quick, literal interpretations of language, the right hemisphere excels in making inferences. Beeman and Chiarello, 1998, Bowden and Beeman, 1998, Mason and Just, 2004. Primed with the flashed word foot, the left hemisphere will be especially quick to recognize the closely associated word heel. But if primed with foot, cry, and glass, the right hemisphere will more quickly recognize another word distantly related to all three, cut. And if given an insightful problem, what word goes with boot, summer, and ground, the right hemisphere more quickly than the left recognizes the solution camp. As one patient explained after a right hemisphere stroke, I understand words, but I'm missing the subtleties. The right hemisphere also helps us modulate our speech to make meaning clear, as when we ask, "What's that in the road ahead?" instead of "What's that in the road ahead?" Heller, 1990. The right hemisphere also seems to help orchestrate our sense of self. People who suffer partial paralysis will sometimes obstinately deny their impairment, strangely claiming they can move a paralyzed limb if the damage is to the right hemisphere. Birdie et al., 2005. With right brain damage, some patients have difficulty perceiving who other people are in relation to themselves, as in the case of a man who saw medical caretakers as family. Feinberg and Keenan, 2005. Others fail to recognize themselves in a mirror or assign ownership of a limb to someone else. "That's my husband's arm." The power of the right brain appeared in an experiment in which people with normal brains viewed a series of images that progressively morphed from the face of a coworker into their own face. As people recognized themselves, parts of their right brain displayed sudden activity. But when magnetic stimulation disrupted their normal right brain activity, they had difficulty recognizing themselves in the morphed photos. Uden et al., 2005, 2006. Simply looking at the two hemispheres, so alike to the naked eye, who would suppose they contribute uniquely to the harmony of the whole? Yet a variety of observations of people with split brains and people with normal brains converge beautifully, leaving little doubt that we have unified brains with specialized parts. Close-up: brain organization and handedness. 7. How does handedness relate to brain organization? Most people also kick with their right foot, look through a microscope with their right eye, and, had you noticed, kiss to the right, with their head tilted right. Gunturgan, 2003. Nearly 90% of us are primarily right-handed. Leask and Beaton, 2007, Medland et al., 2004, Peters et al., 2006. Some 10% of us, somewhat more among males, somewhat less among females, are left-handed. A few people write with their right hand and throw a ball with their left, or vice versa. Almost all right-handers, 96%, process speech primarily in the left hemisphere, which tends to be the slightly larger hemisphere. Left-handers are more diverse. 7 in 10 process speech in the left hemisphere, as right-handers do. The rest either process language in the right hemisphere or use both hemispheres. Is handedness inherited? Evidence that challenges a genetic explanation of handedness. Handedness is one of but a few traits that genetically identical twins are not especially likely to share. Judging from prehistoric human cave drawings, tools, and hand and arm bones, this veer to the right occurred long ago. Corballis, 1989, Steele, 2000. Right-handedness prevails in all human cultures. Moreover, it appears prior to culture's impact. Ultrasound observations of fetal thumb sucking reveal that more than 9 in 10 fetuses suck the right hand's thumb. Hepper et al., 1990, 2004. Such findings, along with the universal prevalence of right-handers, indicate that either genes or some prenatal factors influence handedness. So, is it all right to be left-handed? Judging by our everyday conversation, left-handedness is not all right. To be coming out of left field is hardly better than to be gauche, derived from the French word for left. On the other hand, right-handedness is right on, which any righteous right-hand man in his right mind usually is. Left-handers are more numerous than usual among those with reading disabilities, allergies, and migraine headaches. Geschwind and Behan, 1984. But in Iran, where students report which hand they write with when taking the university entrance exam, lefties outperform righties in all subjects. Nourouzian et al., 2003. Left-handedness is also more common among musicians, mathematicians, professional baseball and cricket players, architects and artists, including such luminaries as Michelangelo, Leonardo da Vinci, and Picasso. Although left-handers must tolerate elbow jostling at the dinner table, right-handed desks, and awkward scissors, The pros and cons of being a lefty seem roughly equal.